Good morning, students. How are you doing? This morning we'll be looking at quadratic and cubic sequence. Quadratic and cubic sequences. Alright. As you can see on the board, I already taught you nth term for linear sequences, and we know that the end result is always in this form. Okay? an plus b. There's always a value attached to n plus a constant b. A and b are constants. Okay. Now we have quadratic sequences with their nth term looking like this: an squared plus bn plus c. And we also have cubic sequences with their nth term being an cubed plus bn squared plus cn plus d. Alright, as we can see, these are the general representations of each sequences: linear sequence, quadratic sequence, and cubic sequence. Alright, so we'll be proceeding to take some examples on quadratic sequences. Alright, in the question here, we are asked to find the nth term of this sequence 3, 6, 11, 18, and 27. Okay, we are asked to find the nth term of 3, 6, 11, 18, and 27. Alright, so there are two methods I'm going to show you on how to solve the problem. So if you look at the board right now, you would see this is the first method, and there are two tables right here. Two tables. Now one table is showing the numbers, and that table is showing the algebraic form of the nth term. The algebraic form of the nth term if it's a quadratic sequence. Now let's get through to explaining it. Now this is 3, 6, 11, 18, 27. 3, 6, 11, 18, and 27. Okay, the first term is 3, the second term is 6, the third term is 4, the fourth term is 18, the fifth term is 27. Alright, so if you find the differences between each of the respective terms, 6 minus 3 will give you 3, 11 minus 6 will give you 5, 18 minus 11 will give you 7, 27 minus 18 will give you 9. Alright, that is why it is termed the first difference. Okay, the first difference. Now if you take a look at the second difference, you are having 5 minus 3 to 7 minus 5 to 9 minus 7 2. It is at the second difference we are able to establish something very common, alright, which is where you stop. Alright, so now you want to talk about the algebraic representation. Now if you go by the algebraic representation here, we have the first, the second, the third, the fourth, and the fifth. Okay, now if I put n equals to 1 into an squared plus bn plus c, I'm going to be having a into 1 squared plus b into 1 plus c. Alright, which gives me a into 1 plus b plus c, which is actually a plus b plus c. Now if you put the value of when n equals to 1 into this nth term representation for a quadratic sequence, you are going to be having a plus b plus c at the end. Alright, you are going to be having a plus b plus c at the end, which is what you have here: a plus b plus c. Okay, a plus b plus c. Now if you do the same thing for when n equals to 2, you would have this. If you do that for n equals to 3, you would have this. If you do that for n equals to 4, and so on and so forth, you are going to have those respective values as you can see on the board. Alright, now we'll talk about the first difference. How did we come about the first difference? The first difference is doing this minus this. Obviously, if you look at it, this minus this, you get 4 minus a, 3a, 2b minus b, 1b, c minus c, nothing. Alright, so if you continue the progression, 9a minus 4a, 5a, and so on and so forth, you are going to arrive at these differences. Okay, you are going to arrive at these values you have here. Alright, now 5a minus 3a is 2a, 7a minus 5a is 2a. Of course, b minus b goes out, so b is not in this particular one on the second difference. Now, if you observe, going by the algebraic representation of a quadratic sequence, you already have 2a, 2a, 2a. Now, looking at what you have here, the next thing is to equate and begin to solve the problem. You equate and you begin to do what? You solve the problem, which is what we are going to be doing straight away. Alright, so going by what we have right on the board, we have that 2a equals to 2. If you equate this to this, you would have 2a equals to 2. Alright, you can see that they are all in the same lining and progression. Okay, so 2a equals to 2. When you do that, you have a to give you 1. A gives you 1. If 2a is equal to 2 and you divide both sides by 2, you have a equals to 1. Alright, pick the next one. 3a plus b equals to 3. 3a plus b equals to 3. Now when you do that, you substitute the value of a. You have 3 into 1 plus b equals to 3, and you have 3 plus b equals to 3. Then b equals to 3 minus 3, and b gives you 0. B gives you 0. Alright, now go to the next one up. You have a plus b plus c. What is the equivalent term here? It is 3. A plus b plus c equals to 3. A plus b plus c equals to 3. Alright, so substitute the values of 1 of a and b into this equation. You have 1 plus 0 plus c equals to 3. And definitely you have 1 plus c to be equal to 3, and c will become 3 minus 1, which will give you what? 2. 3 minus 1 will give you what? 2. Now, at the end of the day, having done all this, you just go ahead and substitute the values for a, b, c, which is up here. Alright, we have a equals to 1, b equals to 0, c equals to 2. Substitute these values into the quadratic sequence nth term like you have here. So I'm rewriting it here. So when you substitute into this value, it becomes 1n squared plus 0n plus 2. And finally, this you have written here is equivalent to n squared plus 2, which is the final answer, which is the nth term for this sequence. I hope you do understand the first method. Alright.